Hey everyone, welcome back to the channel. I hope you are doing great. In today's video, we are going to learn how to move a player using AddForce in Unity. This video is very useful when you want movement to feel more natural. Because instead of directly changing the position of the object, we apply force and let Unity physics system handle the movement. Now in the previous video, we moved the player using transform.translate. That method directly changes the position of the object. It simply and works well for some situations. But when we want movement that interacts properly with physics, we usually use rigid body forces. And that's exactly what we are going to do in this video. So let's start by creating your script. Go to the project window, right click, select create, and then choose C# script. I am going to name the script as player moment. Once the script is created, open it. Now the first thing we need is a variable that controls how strong the movement should be. Because when we apply force to the player, we need some value that decides the strength of that force. So for that I am writing this line of code. Public float move force is equal to 10F. This variable is called move force and it simply decides how much force we apply to the player. If this value is small, the player will move slowly. If we increase the value, the player will move faster because more force will be applied. Now the next thing we need is access the rigid body component for the player. The reason for this is very simple. The AddForce function works with rigid body physics. Without a rigid body, we cannot apply physics forces to an object. So for that, I am creating a variable that will store the rigid body. This variable will hold the rigid body attached to our player object. But right now, this variable is empty. We still need to get the rigid body component from the player. And the best place to do that is inside the start function. Because start runs once when the game begins. So inside the start function, I am writing this. RB equal to get component rigid body. This line is used to find the rigid body component and stores it inside the variable RB. Now our script can access the rigid body component and apply physics forces to it whenever we want. Alright, now that we have access to the rigid body, the next step is to write the movement logic. For movement, we need a function that runs continuously while the game is running. Normally we use update for things that can run every frame. But since we are working with physics here, it's better to use fixed update. Unity performs physics calculations inside fixed update. So for that, I am writing the fixed update function. Now inside the function, the first thing we need is the player's input. We need to know which direction the player wants to move. Unity already provides an easy way to read movement. Input using input.getAxis. So I am going to write these two lines. Float horizontal equal to input.getAxis horizontal. Float vertical is equal to input.getAxis vertical. These two lines read the player's movement input. The horizontal axis controls movement to the left and right, and the vertical axis controls movement forward and backward. Unity automatically maps these axes to common movement keys. So when the player presses movement keys, these values will change between negative and positive values, depending on the direction. Now that we have the input values, the next step is to convert this input into a direction vector. In Unity 3D, directions in 3D space are represented using vector 3D. A vector 3 contains three values, x, y, and z. The x value represents left and right movement, the y value represents up and down, and the z represents forward and backward movement. Since our player is only moving on the ground, we don't want any vertical movement, so the y value will remain 0. So for that I am writing the following. Vector 3 movement is equal to new vector 3 horizontal 0, vertical. What this does is creating a direction based on the player's input. If the player wants to move forward, the z value will increase. If the player wants to move left or right, the x value will change. Now that we have the direction, the final step is to apply the force to the rigid body. So the player actually starts moving. So for that I am writing this line. RB.AddForce of movement into move force. This line applies force to the rigid body in the direction we created. The direction vector is multiplied by force, which controls how strong the movement should be. At this point our script is complete. So let's go back to the Unity. Drag the script and attach it to your player object in the same. Once the script is attached, Unity will run this code during gameplay. Now when the player gives movement input, the rigid body will receive force and the player will move. One thing to keep in mind when using AddForce is that movement may feel slightly slippery. This happens because physics introduces momentum. So the player might continue moving a little even after the input stops. In some games this is actually desirable, especially when you want realistic or physics-based movement. You will often see this type of movement used in things like rolling ball games, racing games, rocket movement, or other physics-based mechanics, where the feeling of momentum takes the gameplay more interesting. And that's the basic idea behind moving objects using AddForce in Unity. I hope this explanation helped you understand how this works. If you found this video useful, just stay tuned to our channel and I will see you in the next video. Thank you.